This example is going to pose a new challenge to us because the two functions that we have are not alike. The non-homogeneous term for x of t is a constant, but the non-homogeneous term for y of t is exponential. And the reason this poses a problem, by the way, our YH is the same because it's the same A matrix. It'll be K1 e to the 2t 0, 1, K2 e to the 3t negative 1, 4. So we don't need to redo that again. But what we do need to look at is what should we guess for the particular solution vector y sub p. So what should this be? Well, we have to be a little bit more cautious here, and here's why. If I write out these equations, 2x plus 5 dy dt equals 4x plus 3y plus 4e to the negative 2t. Well, dx dt, I can almost just solve this exactly as it is using separation of variables. That's no problem. But using this method where I would, have a particular solution, of course, x has to be a constant, right? Because the only way for me to add together two constants and get a constant that is for that constant to be 0. For that constant function to be constant. Finally, we got it. Okay, that function needs to be constant. Okay, but what do we do about dy dt? Because notice that the value of x down here, as soon as we replace x up here with a, and then its derivative will be 0, right? Because the derivative of a is 0. So let me just go ahead and write dyp dt equals, that'll be 0. Now here's where we have to get a little crafty with our guess for dy dt. I made a little more room here. If we follow the same logic, then we know for x, we're letting x of h be a constant. And so in this second equation, we want to make sure that whatever we pick for y, its derivative will equal a constant plus 3y plus 4e to the negative 2t. Well, here's the problem with just guessing in exponential. I'm just temporarily going to put in, let's say we thought it would be something of the form be to the negative 2t, which is not altogether wrong. And that would mean that its derivative would be negative 2b e to the negative 2t. So this is kind of like what we've done before. But now notice what's going to happen. If I plug in the derivative for y, which will be negative 2b e to the negative 2t, and I equate that to 4a plus now 3 times y. If y is be to the negative 2t, I'll plug that in for y, and then plus 4e to the negative 2t. Now, it's good because I can equate the exponentials together and say that, hey, this term here on the left has to equal the sum of these two terms on the right. And then I can find the value of b that accomplishes that. But the problem is I have an extra constant here on the right hand side, but on the left hand side I don't, because the derivative of an exponential is, well, it's an exponential. It doesn't introduce a standalone constant term. So here's a way we could handle that. If some way I could either get a constant into my derivative, which would require my guess to have a linear function, because the derivative of linear is constant. That would be one way, possibly, but here's kind of an easier logic. What if we let y be an exponential plus a constant? If y is an exponential plus a constant, then we can ensure that whatever that constant is, that it plus 4a will cancel out and zero out the constants on the right-hand side. Okay, again, right now my problem is this 4a. I can't have that 4a on the right because I don't have a constant to match it to on the left-hand side. I mean, I could say 4a equals 0, but then I get a equals 0, and that's going to be a contradiction because a is actually going to need to be negative 5 halves, just like it was in our previous problems, because we didn't change the non-homogeneous term. So that's going to be a contradiction, and we can't let that happen. So let's do this. Let's do exactly what we do, which is I need to approach this as I need to cancel out that constant. So I'm going to add a constant here. I'll call that plus c. Okay, its derivative is still negative 2b e to the negative 2t. So that means that I have negative 2b e to the negative 2t, still just an exponential function, equals 4a plus, now 3 times y will be b e to the negative 2t plus c, plus 4e to the negative 2t. And now if I distribute, I have negative 2b e to the negative 2t. I will have, distribute the 3 there. Notice that I'll have 3b e to the negative 2t's plus 4 more e to the negative 2t's. So you can verify this or work through this, but with just combining this term and this term, I can factor out an e to the negative 2t and have 3b plus 4. Then when I distribute here, the 3 to the c, I'll have plus 3c. Now, if you're like, well, where did the 4a go? Well, I'm still going to write the plus 4a plus 3c on the end like that. Now I can match things up because I can get that constant on the right to cancel out. I know that the negative 2b, the coefficient of e to the negative 2t on the left, has to match 3b plus 4, which is the coefficient of e to the negative 2t on the right. So that means negative 2b equals 3b plus 4. Another equation that I can extract from this is, well, how many constants do I have, or what are my constants on the left-hand side? Well, it's plus 0, right? So this term right here, this plus 0, needs to equate to my constants on the right, which is 0 equals 4a plus 3c. And then finally, for my really first equation that I should have written down, that's going to be that 0 equals 2a plus 5. So from this top equation, there's only one unknown, but because down here I have more unknown, you see we get a couple more equations out of this. Now, you can enter this into a solver, but let's go ahead and just see here that we could solve for a, subtract 5, divide by 2, a is negative 5 halves. Now that means a is negative 5 halves over here, so we get 0 equals 4 times negative 5 halves plus 3c, so now I'm plugging in over here. And I have 0 equals negative 10 plus 3c. Okay, if I add 10 to both sides, I get 10 equals 3c, and c equals 10 thirds. So I have a, I have c, and now I need to get b. Now remember, b is the undetermined coefficient. Subtract 3b over here. I actually don't need any of these steps to be able to get b because this is an equation of b alone. So negative 5b equals 4, and therefore b equals negative 4/5. There we go. And that means that now if I come back over here, my y particular will be a, which we just found to be negative 5 halves. And then my exponential needs to be negative 4/5 e to the negative 2t plus c. And once again, now we'll take our y sub h, which is this guy here. I'm not going to go ahead and rewrite, well, I guess I can rewrite it, plus yp, which is this guy here. So we get y is equal to k1 e to the 2t 0, 1 plus k2 e to the 3t negative 1, 4 plus negative 5 halves at the top, and then negative 4/5 e to the negative 2t plus 10 thirds. Very nice. So that's how we solve that non-homogeneous. So you can see that this quickly picks up, and this is quickly going to get more complicated if we don't get a hang of it, because of course even just adding having one function be a constant and the other an exponential does in its own right pose some problems. So let's see if we can strategize a little bit more to how we might do this in general.